Hello everyone, welcome back to Hydrology Hub, the place where we make hydrology simple, scientific, and super interesting. In today's video, we are going to explore one of the most powerful techniques used in flood modeling, watershed analysis, and hydrological simulations. That is rainfall runoff modeling in HEC-HMS using catchment DEM. Whether you are a student, researcher, or industry professional, this video is going to give you a complete practical walkthrough. So let's dive right in. So once you will open the HEC-HMS, so you will get this window. Now here in this example, we will use the dam, and from the dam we will delineate the watershed and develop the basin model to create the rainfall runoff model in HEC-HMS. So first of all, we'll go to the file, go to the new, and we'll create a new project like RR HEC-HMS underscore watershed. Okay, create this one. So this project is created. Now go to the component, then select the terrain data manager, click on the new. Terrain 1 by default name has come, we will take the same name. Then next, select the DEM where your dam is kept. So I have kept the dam here. Select your dam. So for this you have to download the dam of your catchment area, and for downloading the processing the dam, or if it is a large catchment, you have to mosaic the various tiles of the dam. So I have already given a separate video in my channel Hydrology Hub. You can go through those videos and see how to download the dam and how to process the dam, how to merge the dam. Okay, so finish. So now the dam is created. Okay, after that you can see that terrain is there. Now here go to the component again, click on the basin model manager, create new basin 1, take the default name. So that basin model is created. So in the basin 1, select the terrain 1. Okay, again go to the terrain. So it will ask about the coordinate system. Select here and browse your coordinate system. So here is the PRJ file. Now again for the dam, how to create the PRJ file means the your coordinate file. You can again go through my videos. So I have already explained how to create the coordinate file. Okay. So in my channel, all those videos are available. So this is there, terrain 1. Now you can see again link this one, terrain 1 here, and click over there. So it will upload the terrain 1. So now the terrain 1 is uploaded. So your dam is uploaded here in under the terrain 1, right? Now there is one option, GIS is there. You can see in the GIS, first one is the coordinate system that we have already provided the coordinate system. Now second is you go to the pre-process the sync. So we'll pre-process the sync here. It has been pre-processed. Again, go to the GIS, then pre-process the drainage system. So now the drainage will be processed. It is also pre-processed drainage. Now identify the streams. So by default, it will give certain value, certain area for which. So smaller will be this area, the more will be the stream. So in this example, I am taking uh, larger streams only. I am considering. I am just neglecting all the small stream for simplicity purpose. So I'll take here this value as suppose 250 square kilometer. So few streams will be developed, and then you can see very few streams have been developed. Now zoom this streams. So go to a particular stream over there, right? I'll create now the watersheds and the basin model. Now for that, you select this one breakpoint, and I'll take the breakpoint there. On the channel, you have to just click the breakpoint. Remember, it should be on the channel itself, should not be outside the channel. Okay, so these are the channels. So I marked the breakpoint over there. After that, again go to the GIS and click on the delineate elements. So it will delineate subbasins. For subbasin, I have given the subscript as subbasin S, and for reach, I am giving the preface as R. Okay. So now it will create the sub-basin reaches and develop the model also. And that model will come in the your basin model setup for this one. So all the element it will create. You just see it has developed the model. So elements also created in sub-basin models. So you can see that the basin model is all created. Okay. So one by one we'll see in the sub-basin S2, if you see, it has mentioned that how much area is there for S2. Okay, for S2, how much area is there. Okay, then you have to select the methods here for computation. So loss method I am selecting here as SCS curve number method. Yes, and then transformation method SCS unit hydrograph method I will select. SCS unit hydrograph method. Yes, and I will take the base flow as none for simplicity purpose. Okay. Similarly for S1 I will take my model as SCS curve number method, transformation method again SCS unit hydrograph method, and this one as none. Okay. Now similarly for the reach one I'll go, I'll select for the reach one, I'll consider it as a Muskingum routing method. Yes. Then here routing will provide the routing parameter K suppose 1 and x is equal to 0.2. Okay. Then for next basin S3 will give the values here SCS method, again SCS unit hydrograph method, then base flow none again I am taking. Okay, then for the loss we'll see the curve number as 65, transform as 50. Okay, similarly for other basins also we'll provide these data. For S1 we already given here lag time, and we'll provide for S1. What is the lag time for S1? S1 is lag time is suppose 80 and curve number is 70, and for S2 our curve number is 60 suppose, and this transform is 55. Okay, so we have provided all the data for the basin. Now go to the component again, go to the time series. So we'll provide the time series data. Okay, new is the gauge 1 we will create, precipitation gauge 1. We will create one more gauge 2, create. Okay, now here you can see for gauge 1 for the time series we will provide the data for the gauge 1. Time interval we are taking as 1 hour, right? Then after that go to the compute. Oh, sorry, this one we have selected. Then after that you select here and then give the time. Okay, 1st January 2000 hour to 2nd January 2000 hours. We'll give the rainfall time series 10, 20, 40, 23, 5, 0, 0, 0, 0, 0, 32, 45, 50, 6, 3, 0, 0, 0, 0. Okay. Now similarly for the gauge 2, we'll provide the data. Time interval is 1 hour. Okay. And here we'll select that time period is same, 1st January to 2nd January, and rainfall will provide 21, 23, 43, 10, 14, 10, 10, 11 or 12, then 0, 0, 0, 0, 0, 20, 23, 14, 17, 0, 0, 0, 0, 0. So you can see the graph also, this one. Similarly, you can see the graph for another rain gauge also. This way we have entered the precipitation data. Okay, so the time series data is also entered. Basin model is created, time series is there, then the terrain data is there. Then in the component again go and here select the control specification model, create this one control specification model, then go to the control specification model. Here in the control specification we have to provide the time period for which we have to create the simulation. So we will provide 01 Jan, same as what we have given for the rainfall data series. Okay, 0000 hours. Then 02 2nd January 2000 to 00 hours, and here 1 hour. Okay, so this specification we have also provided. Now next we'll go to the component again. We'll create the meteorological model. So we'll create this meteorological model as MET1. Create this one. So MET model is created. Just expand this one. Go to the MET1, and after that go to the basin and include the sub-basin. Yes, and that means here what you are doing, you are trying to link the various rain gauges with the sub-basins. Select the specified basin, sub-basin. So for S1 sub-basin, suppose rain gauge 1 is affected by, or the rainfall data is being covered from the rain gauge 1 in S1. In S2, it is covered by the rain gauge 2. Similarly, S3 is covered by the rain gauge 2. Okay, so this way we have provided all the data. Okay, now after that you go to the compute, create model, simulation run. Okay, we will create that simulation run. Just next, finish. Then select the run one and run the model. So model is successfully run. Close this one, go to the result and see the results. Run one. So this is a global summary. It shows that how much discharge is there from each subbasin, peak discharge, how much is there, what is the time to peak, and what is the volume for each subbasin or component. So here, for subbasin wise also you can see the graphs. Okay, flood hydrograph, what is, how much is the rainfall, how much is the loss, everything is just computed. You can see the summary table, you can see the time series for the subbasin 2. Similarly, for the subbasin 1, you can see the graph, you can see the summary table, you can see the time series of the data. Similarly, for reach 1, you can see what is the inflow hydrograph and the outflow hydrograph. You can see the summary table. Okay, you can see the time series. Okay, similarly for the S3, basin S3 also you can see rainfall runoff. Okay, so you can see the summary table, time series table. Okay, and then finally at the sink, what is the final hydrograph at the sink, at the outlet. Okay, means from all the three basins and the reach, how much flood water is coming at the outlet. So this way you can just see all the summary table and the time series. You can develop a rainfall runoff model using the DEM. Thank you so much for watching this lecture on rainfall runoff modeling using DEM in HEC-HMS. I hope you found the explanation helpful and easy to follow. If you enjoyed the video and learned something new, please like, share, and subscribe to the channel Hydrology Hub. Don't forget to press the bell icon so that you receive instant notification whenever we upload new videos. Our channel also offers a complete lecture series on downloading and processing DEM, using DEM in hydrological modeling, HEC-RAS modeling and flood simulation, many other tools and techniques in hydrology, water resources, and GIS. Stay connected with Hydrology Hub for more informative and practical tutorials. Thank you once again. See you in the next video.